when you try to optimize a quadratic equation, you are trying to find the vertex. If you remember from grade 10, there were two different ways for you to find the vertex of a parabola. One was averaging the zeros, and the other was completing the square. So we're just going to do a quick refresher on each method before I show you a grade 11 little shortcut and trick to finding the vertex. So does the function h of x have a maximum or minimum? So because our a value is negative, that means our parabola is opening down. And if it opens down, the vertex is a maximum. So let's go ahead and use our averaging the zeros method. But that means first thing we should do is find the zeros, which means set your equation equal to 0. And while I set my equation equal to 0, I am going to common factor out that negative 2 to get x squared plus 5x minus 6, and now I have a nice simple trinomial that I can factor. So I need two numbers that multiply to negative 6 and add up to 5, and those magic numbers are 6 and negative 1. So x plus 6, x minus 1. So then when we branch out, our zeros are negative 6 and positive 1. So now that I know my zeros, I can average them to find the halfway point, which would be my axis of symmetry, or the x-coordinate of my vertex. So negative 6 plus 1 divided by 2 is negative 5 over 2, and we are going to keep it as a fraction, and we will just deal with it. So now to get the entire vertex, or the optimal value, I'm going to put this x value into my function. So negative 2 and then negative 5 over 2 squared minus 10 times negative 5 over 2 plus 12. I'll start off by applying that exponent. So I'll have positive 25 over 4. I will do my multiplication here. So a negative times a negative is positive. And then 10 times 5 is 50. 1 times 2 is 2. And now for the multiplication at the start here, I would have negative 50 over 4, but I know that would reduce to negative 25 over 2, so I'm just going to do that in one step. And now I notice my first two fractions are over 2, so I'm going to turn 12 over 1 into something over 2 by multiplying top and bottom by 2, and that would be 24 over 2. So then when we add up, we end up with 49 over 2. So that means our vertex is negative 5 over 2, comma 49 over 2. And that 49 over 2 is the optimal value. And since we said it's a maximum, we have a max of 49 over 2. And that's your averaging the zeros method. This method is nice if you're given a quadratic equation that's already in factored form, or you had to factor it for another reason. Completing the square is ideal if you can't factor your expression or it's already in standard form. So does the function q of x have a max or a min? Well, our a value here is positive, meaning our parabola opens up. So we do have a minimum. So to complete the square, we're not going to set our equation equal to 0. So I'm just going to keep my q of x. But our first step is to factor out the 3. And only from the first two terms, which means that positive 16 is going to stay outside just because we are going to need a constant outside of our brackets to give us the optimal value. Now, what I have inside my brackets, I need to turn it into a perfect square trinomial. So the way we do that is by taking the negative 4, dividing it by 2, and squaring it. So negative 4 divided by 2 is negative 2. And then when we square it, it's always going to be a positive number, and it's positive 4. So now we can take this positive 4, and we're going to add it and subtract it to our bracket. And it's important you add and subtract because technically 4 minus 4 is 0, so you haven't really changed anything. But I have created a nice perfect square trinomial for myself. Now that negative 4, I need to kick it out of the bracket, and I'm going to do that by multiplying it by the 3. So 3 times negative 4 is negative 12. And now for your final step, we can collect our like terms to get the optimal value, and then we can factor our perfect square trinomial in our bracket to get the axis of symmetry. So the square root of x squared is x, the square root of 4 is 2, and I take the sign of this middle term, which is negative. And then don't forget to put your bracket to the power of 2. And then negative 12 plus 16 is 4. So that means our vertex is positive 2 comma 4, because we always take the opposite sign from the number inside our bracket. And now because we had a minimum, we have a minimum of 4. And there it is. Those are your two methods from grade 10. Now let's look at another method, our grade 11 method, which is called partial factoring. So we can use partial factoring, and it's very similar to averaging the zeros, but we're not actually fully factoring. And this partial factoring relies on the fact that every set of points has symmetry. So if we have a parabola, let's say like this, and this vertical line is the axis of symmetry, any set of points that are directly across from each other, they have symmetry. So let's say this was my x-axis. We know that these are the zeros. And we know with averaging the zeros, we take our two x-intercepts and we average them. But you don't only have to average zeros. Let's say I took this point here and this point here, and they have the same y-coordinate so that they're in the same line. If I average them, I'll still get my axis of symmetry. Now, to make our life easier, let's pretend that this point here was actually on the y-axis, so that this point is your y-intercept. If you set your equation equal to the y-intercept and you bring everything over to one side, you will see that you end up with a really easy factoring method. So what we're going to do is set our equation equal to the y-intercept to solve for the other symmetry point. And then once we have 2 points that have the same y-coordinate, which will always be the y-intercept, we can average them to get our axis of symmetry. So let's try it out. I have this equation x squared minus 4x plus 5. The y-intercept is 5. So I'm going to set my equation equal to 5. Now watch what happens when I bring the 5 over. When I bring it over, I know I have to change its sign. So it's going to be minus 5. And now 5 minus 5 is 0. If you always set your equation equal to the y-intercept, that constant will disappear. And if it disappears and you don't have that c value at the end, your variable will always be a common factor. So I can factor out x, and then I'm left with x minus 4, which means my solutions here are 0 and 4. So these are the two coordinates we have. We have 0, 5, which is the y-intercept, and 4, 5. So let me just do a quick little sketch here. Let's say 5 is here, and that's the other point we found. And our parabola is opening up. So we have just found those two values. If we just average them, we'll still get our axis of symmetry without bothering to solve for the actual x-intercepts. Because if we solve for the actual x-intercepts, we might have to do quadratic formula or factor with a more complicated method. But using partial factoring, you will always just rely on common factoring. And now that I have my values, I can average them as usual, but one of the solutions will always be 0. So really, I just have to take the 4 and cut it in half to get 2. Now I know my axis of symmetry, and I can plug this into my parabola. So 2 squared minus 4 times 2 plus 5. So we have 4 minus 8 plus 5, which is 1. So our vertex is 2, 1. So we have a minimum of 1. Now this partial factoring method only works if you're trying to find the vertex. You can't use this method to just solve a random equation. This is primarily and only for solving for the vertex. And it just saves time because you are using a more efficient and quicker, easier factoring method. So let's try another one. So I want you to try this on your own. We know that our y-intercept is 3 for this equation. So I want you to set your equation equal to 3, bring it over to the other side, do your quick common factoring, and sometimes when you common factor, you might also be able to factor out a coefficient to make your life easier. If you want, it doesn't matter, it will work either way. Solve for x, average them, then get your vertex. So pause it, try it out, then come back to the video. So you should start with 3 equals 4x squared minus 12x plus 3. When we bring the 3 over, they cancel each other out. And now I will factor out a 4x so that x equals 0 or x equals 3. Now you could have also just factored out an x and you had 4x minus 12 here. And when you branch out, you still get 0 as a solution. Just over here, you will have to actually solve your bracket fully. So bring the 12 over, divide out the 4, and you still get the same thing. Just be careful with the coefficient. So now that I have my solutions, I can average them to get 3 over 2, and we're just going to keep our fraction. I don't want to see decimals. And then I'm going to go to f at x and sub in 3 over 2. So 4 times 3 over 2 squared minus 12 times 3 over 2 plus 3. And now let's clean up. I'll do my exponent first so that I have 9 over 4. And then the 12, I'll put it over 1. And if I multiply it, I'll have negative 36 over 2. But 36 over 2 will simplify to negative 18. And now when I do 4 over 1 times 9 over 4, it'd be 36 over 4, but that does simplify to 9. So I have 9 minus 18 plus 3. And that will just give me negative 6. So my vertex, and hopefully your vertex, is 3 over 2, comma negative 6. And that, because it opens up, it's a minimum of negative 6. So that's our optimal value there. So that's partial factoring. Hopefully you like it and see its benefits, but you really have to understand why this works and what it is used for, which is only for optimization, only if you're looking for the vertex or that max or min value. So now let's take this idea and apply it to application questions you would have seen in grade 10. So everything we're going to do right now should look a little familiar, nothing super fancy. It's just we're going to change the way we find our vertex. So let's start off with a profit example where we're actually given the equation. So the profit produced from selling dirt bikes can be modeled by the function p of x, where p is the profit in thousands and x is the number of dirt bikes produced in thousands. I am going to highlight this profit in thousands and bikes produced in thousands because that will be very important in terms of what you plug into your equation or the numbers coming out of it. So question 1, will the profit ever reach 16,000? So first of all, if the profit is 16,000 and we know P is the profit in thousands, we're going to take this 16,000 and divide it by 1,000 to actually get what we'd be plugging into our equation. So P is actually equal to 16. So now that I have that, I can set my equation equal to 16. Now the thing is that it asks you if the profit will ever reach that amount. So really we can just use the discriminant here to see if there isn't actually a solution to this equation, because I don't really care about when it will reach that profit, just will it ever be able to. So you have to look out for those key little words to know what method you should be using. Plus, this is more of a solving an equation type of thing, not an optimization. So make sure you can differentiate between the two. So we will bring that 16 over to the other side, and it will be 8 minus 16, so negative 8. And now let's use that discriminant, so b squared minus 4ac, and we end up with negative 15, meaning our discriminant is less than 0, so there is no solution, meaning the profit will never reach 16,000. So therefore, the profit will never reach $16,000. And the trick here was really knowing to put 16 in for P and not 16,000. B, how many bikes need to be sold to make a maximum profit? And C, what is that maximum profit? So I see the word maximum. This is making me think of the vertex. So to find the vertex, I have three options. I can factor that and average the zeros. I can complete the square, which I don't really want to do because I don't want to factor out a -2 out of the 7, because then I'm going to have fractions and I don't feel like dealing with it. Or option 3 is partial factor. So I'm going to do that because it is a lot quicker. I see that my y-intercept is 8. So I'm going to set my equation equal to 8 to find that symmetry point. And when I bring the 8 over, it cancels everything out, or the constant out. And now I can factor out an x. And actually I'm going to factor out a -x so that I have 2x subtract 7. So one of my solutions is 0 as expected. And the other one, I'm going to bring the -7 over to the other side and divide both sides by 2 to get 7 over 2. And now I'm going to average it, which really just means I'm going to take the 7 over 2 and divide it by 2. So I'm going to write it like this, but instead of dividing by 2 over 1, it really means I'm multiplying by the reciprocal. So 7 over 4 is my XV, or my axis of symmetry. And now that answers question B, how many bikes need to be sold? So I will actually turn this into its decimal. So 7 over 4 is 1.75. That doesn't mean you're selling 1.75 bikes, because if we look at our scenario, X is the number of dirt bikes produced in thousands. So I'm going to multiply this by 1,000 for my therefore statement. And when I multiply it by 1,000, I get 1,750 bikes. And now to actually find the maximum profit, I can take this value and sub it into my P of X. But before we do that, let's just write our therefore statement. Therefore, okay, so for C, we're doing P at 1.75. So -2, 1.75 squared plus 7 times 1.75 plus 8. And we can just plug that into our calculator all at once. We get 14.125. Keep all the decimals because once again with profit, it's in thousands. So our actual profit is going to be 14,125. So therefore, the max profit is $14,125. And that's it. So for B and C, we were using that partial factoring to find the vertex. But for A, it had nothing to do with the vertex because we don't see the word maximum. So I knew it was just a typical solving equation without the solving because I just wanted to see if there was a solution. All right, let's try a revenue question that is very, very similar to grade 10. And it might actually just be taken straight from grade 10. So you run a canoe rental business on a small river in Ohio. You currently charge $12 per canoe and average 36 rentals per day. An industry journal says that for every 50-cent increase in rental price, the average business can expect to lose 2 rentals a day. How much should you charge to maximize the revenue? So remember, revenue is going to be, in this case, the price times the number of rentals. So I know I start with a $12 fee, and I'm going to be increasing the price by 50 cents or $0.5. At $12, I get 36 rentals, but if I increase the price, I decrease the rentals by 2. So in both of these scenarios for price and rentals, it depends on how many times I'm increasing the price. So you will need let statements, and X is always going to represent the number of price increases. And then we are dealing with revenue, so let R represent revenue. So now let's set up that quadratic equation like we did in grade 10. So one bracket will be for price, one bracket will be for sales. So I start off by $12 and I increase the price 0.5 x times. So I'm going to multiply that 0.5 by x. So if I increase 5 times, I do 0.5 times whatever, and then I'll add it on to 12. Same thing with the rentals, 36 subtract 2x, because if I increase the price x times, I would multiply 2 by x to see how many sales I'm going to lose, and then I'll do 36 subtract that number. Now that I have my nice equation, I see it's already in factored form. Because it's in factored form, I'm not going to bother doing any partial factoring because that would require me to distribute this and turn it into standard form and then do the partial factoring, which is a waste of time. So we're just going to do it in the exact same grade 10 way, which is set your revenue equal to 0 and solve for those x-intercepts. So we'll set each bracket equal to 0 and isolate for x. So bring the 12 over, becomes negative, divide out the negative or the 0.5 and I get negative 24. I do the same thing for my other bracket, bring the 36 over, it becomes negative. I divide both sides by negative 2 and I get positive 18. Now I take these numbers and because I saw the word maximum, I know I want the vertex, so don't forget to do your XV, which is just the x coordinate of the vertex. So I add them up, divide by 2, and we get negative 3. So that actually means your price is going to decrease, not actually increase. So going back to the question, it says how much should you charge to maximize your revenue? We don't actually care about what that maximum revenue is. So that first bracket represented price. So I'm just going to plug that negative 3 into x only in that bracket. So 12 plus 0.5 times negative 3 to get 10.5. So therefore, you should charge $10.50, and that would maximize your revenue. Okay, so every scenario is different on what method you need to choose, but also remember you need to know whether you're actually solving an equation or trying to find the vertex. And the key word is, if you see the word max or min, then it's finding the vertex. Any other time, you're just solving the equation using quadratic formula or regular factoring. Okay, let's try another common grade 10 example. A garden is to be sectioned off into 3 sections. I'm going to start off with a diagram right away. So if that's my rectangle, or that's my garden, and I need 3 sections, I need to put 2 dividers. So if there are 200 meters of fencing available, what are the dimensions of the garden that will produce a maximum area? Okay, so let x represent length and let y represent width. Or the other way around, doesn't matter. So this is going to be x, this will also be x, and then I have 4 widths I have to worry about. And now I know I'm going to maximize the area, and my area formula is x times y, or length times width. So I'm also going to put an area let statement. Let A represent area, just to communicate well. But this I can't actually find the vertex of because it doesn't really look quadratic just yet. So I need to use that 200 meters of fencing, which is kind of like perimeter, except because my garden is sectioned off, I have a bit more. So that 200 meters is going to cover 2 x's and 4 y's. So 2x plus 4 y's is equal to 200. And this is clearly linear, so I'm going to just use this equation to isolate for a variable that I will then sub into my area formula. So I'm going to isolate for x just because it's going to be easier for me to divide out a 2 than a 4. So 2x equals 200 minus 4y. Then I divide everything by 2 so that I have 100 subtract 2y. This is what x is equal to, and I have an x right there, so I'm going to do a little substitution. So area equals 100 minus 2y times y. and I need to find the vertex, and this is actually in factored form again, so I'm just going to average the zeros the proper way, no partial factoring. So for good form, I'm going to set my equation equal to 0 to show that I'm solving for my x-intercepts, and I get 0 for y as one solution, and for the other, I'm going to bring the 100 over, divide out that -2, and I get 50. So now I average them, and I don't write xv because I did end up solving for the y variable. 50 plus 0 divided by 2 is 25. And if I go back to my let statements, y represented the width. So the width is going to be 25. And if I want to find the length, which was x, I just go back to that x equation I came up with. So x equals 100 minus 2 times 25, which is 100 minus 50. So that's 50. And that would be my length. So therefore, the garden is 25 meters by 50 meters. And that's it for that one. And now let's try one more optimization question. Two numbers have a sum of 16. If their product is a maximum, what are the two numbers? And this again is something you would have seen in grade 10. So I have two numbers, so let x represent first number, let y represent second number. Remember, your let statements are always going to be the two things that you're looking for. So in the previous one, I was looking for length and width, so that's what x and y was. For this one, I'm looking for the two numbers, so x and y represent the two numbers. Now I know I'm maximizing, so I need the vertex of the product. So I will let p represent product. And the product equation would just be p equals multiplying the two numbers, so x times y. But of course, this isn't quadratic, so I am going to require that sum of 16 information. So that means if I take x and y and I add them up, I get 16. This is again linear, but it is useful for me because if I isolate for a variable, so let's say this time I isolate for y, I get 16, subtract x. So if this is what y is equal to, and I see a y here in my product equation, I can do a nice little swap. And now, once again, I'm not going to do partial factoring here because it is actually in factored form already. So I'm just going to set my product equal to 0. One of the x-intercepts is 0, and the other, be careful here how you isolate for x. I'm just going to bring it to the right, so that 16 equals x. So it should be positive 16, not negative 16. And now my xv would be 0 plus 16 divided by 2, which is 8. And x represented the first number. They didn't ask me about what the product is, so I'm not going to take this and plug it into my product equation. I'm just going to plug it into that y equals 16 minus x, but 16 minus 8 is 8, and that's my second number. So therefore, the two numbers are 8 and 8, and that will maximize the product. So all of these scenarios, if you see the word max min, you know you're looking for the vertex. If it's already in factored form, then you want to do your regular averaging the zeros. If it's in standard form, so usually when I give you an equation, then partial factoring would be a little better, but you can still use your averaging the zeros or completing the square method if you want, if it's not specified. But just a reminder that those three methods are only if you want to find the vertex. If it just asks you to solve the equation, you are just doing regular full-on factoring or quadratic